Hello everyone. Today let's solve the problem Omkar and the heavenly tree. Right? Omkar and heavenly tree. So this was asked in Technocup 2022. This was asked in Technocup 2022 elimination round. Right? First round of the elimination. So this was asked in Technocup 2022. So the question is Omkar and the heavenly tree. So this is just pure tree based question. You can just go through the question and try to understand the question, right? So I'll just summarize the question so that it will be easier for us to understand, right? You can just go through the question. It is very easy to understand, right? So here till here the question is still here. Basically the other part is input and the output. So I can just go through the question. In my opinion, I'll just summarize the question so that it can be it will be easier for us to solve the problem, basically, right? So here let me uh, so what the question states here, we are given n nodes. So just give me a second, 1 second here. Yeah, we are given n nodes, right? So we are given n nodes, m restrictions. We are given m nodes and m restrictions. So this one I'll just give r, right? Or restrictions. We are given n nodes and m restrictions. Each restriction a comma b comma c says node b must not lie on the path between the nodes a and c. So node b shouldn't lie on the path between node a and c. This part is very important, right? This part is very important. So again I want to tell you the same thing here. Node, we have been given n nodes. N is nothing but the number of nodes here, and m restrictions, m is nothing but restrictions. They have I'm telling that one directly. This is nothing but the number of nodes. M is nothing but the restrictions, right? So each restriction here, each restrictions, we can consider this one and this way. Each restriction ABC says here node B shouldn't lie on the path between node A and C. Node B shouldn't lie on the path between A and C. Between A and C. So this part is very important. Again, I'm telling this part is very important. For each restriction A, B, C says node B must not lie on the path between nodes A and C. We need to construct a valid tree. We need to construct valid tree means with the n minus 1 edges. With the n minus 1 edges satisfying all such restrictions. Again, we need to construct the valid tree satisfying all such restrictions. We are guaranteed that a solution always exists. So this is nothing but the edges or vertices. We have to construct a tree, or we have to construct a valid tree with the n minus 1 edges satisfying all such restrictions. Satisfying all such restrictions. So this part is very important. We are guaranteed that a solution always exists. We are guaranteed that the solution always exists. Solution always exists. So this is what the question states, basically. Simple to understand, right? So again, I'll just read this one out loud. Just try to get the question, right? So here we have been given n nodes and m restrictions, and we have been said that each restriction a comma b comma c says node b must not lie on the path between node a and c. Node a and c, this one, right? It shouldn't lie on the path of a and c. So we need to construct a valid tree with n minus 1 edges. We need to construct a valid tree with n minus 1 edges, or the vertices satisfying all such restrictions. So this part is main thing here, restrictions part, right? So we have to construct a valid tree satisfying all such restrictions. We are guaranteed that a solution always exists. So this is the question mainly. I hope the question part is completely clear. Let's come to the example part here, whatever the example that they have given here, right? So let's come to the example part here. So this is nothing but here, just give me a second. So within first input itself, we have this one, two input. So this one, we are considering another, this one, what do we call another input. So this one we will consider till this one. So this is nothing but n. Number of nodes is 7. So this is 4 is nothing but the m restrictions, means we have 4 restrictions here. We have been given 2 inputs. So this is one input, and this second one 5 3, number of nodes is 5 here, this one, and 3 here. This is nothing but the m restrictions. 3 is nothing but the m here, right? So 1 2 3 2 3 4 3 4 5 we have been given. This is another input. Let's consider the first input for the this one. What do we call approach? To discuss the approach, we will be going with the first input. We'll be going with the first input. Again, I'm telling this one, just remember this one, we will be going with the first input, and multiple outputs exist for the inputs. Multiple outputs may exist for the input. You are not guaranteed that every time we have to get the same output here. 1 3 1 2 1 3 3 5 3 4 2 7, this one we have been given here, right? So multiple outputs can exist for the single input, right? So just keep this in mind. So we will be considering this part. So here 7 4, we have been given two inputs. This 2 indicates that we have been given two inputs, right? So we are considering the first input from here to here. From here to here, we are considering the first input. The output that we need to get here is still here, basically. From It can consist of multiple output, don't worry. We just have to concentrate on the approach as well as writing the coding part, right? So whatever the code we write, so basically we have to concentrate on the approach first, followed by the complexities. These two, if we concentrate correctly, and if we get every step correctly, then writing the code will not be a big deal, right? Writing the code will not be a big deal if we get the approach and the complexities correct. uh, right, so I hope this is the output that we need to get here for the two outputs as a whole, for this input and for this input totally. So we have two inputs. For the two inputs, the output that we need to get here is this one. Output that we need to get here is this one, right? So I hope the question part and this one example, this one input output part is completely clear, right? So they have given us wonderful examples just for the sake of understanding. So I hope the question part is completely clear as well. I hope the question part is completely clear as well. Now what shall we do? Let's do one thing here. Let's discuss the approach first, followed by the complexities, and then let's write the code. As usual, let's discuss the approach first. So here I have considered the first input. As I have said in the first example, they have given two inputs for us. So we have considered the first part of the input. This is nothing but the number of nodes 7. This is nothing but the this one. What do we call M, restrictions? Restrictions, right? This is nothing but the 7 is nothing but the number of nodes, and here 4 is nothing but the restrictions. The input is this one: 1 2 3 3 4 5 5 6 7 6 5 4. So we have n nodes here. N is 7. We can clearly see here 1 2 3 4 5. 7 is the highest, right? 7, the value is 7 higher. The value 7 is the largest value here. So n is nothing but the 7 number of nodes, and m is nothing but the restrictions that they have kept here. In this case 4, they have given 4 as m, right? So what we need to this one, basically what we need to find out here, just give me a second here. So I forgot what we need to find out, man. We have to make sure that this one b, we have to make sure that this one b, every part of the b, right? So this one part of the b must not lie on the path between a and c. It shouldn't lie on the path between a and c. This one, so 3, this one, this 5 and 7, so this one 6 and 4, right? So these things we have to make sure. So the output that we need to get here is this one. The output that we need to get for the particular input is this one: 1 2 1 3 1 4 1 5 1 6 1 7. B shouldn't, so here basically accordingly with the question, B shouldn't lie on the path between nodes A and B. Nodes A as well as B. Nodes A as well as C. Sorry, I got confused here. B shouldn't lie on the path between nodes A and C. So here this one is A, and again this one is C. The middle one is B. B shouldn't lie on the path between nodes A and C. So that is what we need to return here, right? So that is what we need to return. We need to construct a valid tree with the n minus 1 edges or the vertices satisfying all such restrictions, right? So this is the output that we need to get here. You can clearly see by seeing itself, you can clearly see B doesn't lie between the nodes A and C, right? So 1 and 2 it doesn't, 1 and 3 it doesn't, 1 and 4 it doesn't, 1 and 5 it doesn't, 1 and 6 it doesn't, 1 and 7 it doesn't. So here the output that they have given in the this one, what do we call, example of I mean, for the input one in the example is different. So we can have the multiple outputs for the same input, right? So we just have to construct a valid tree with n minus 1 edges that satisfies all the restrictions. That's it. This the input, the same input can have the multiple outputs. Just keep this in mind for this particular question, right? So let me come here. Let's go with the step-by-step explanation here. Let's move on with the step-by-step explanation here. For each restriction a comma b comma c, this one I'm speaking of. For each restriction a comma b comma c, cannot be on the path between A and C. This one we have already discussed this one. This itself we have to find, right? So for each restriction A comma B comma C cannot be on the path between A and C. So we will avoid making B the central node of the tree. We will avoid this one, B making the central node of the tree, central node of the. So this one is A, this one central. We will avoid this one, right? Suppose this is B, C, this is C, right? So we will avoid making B central node of the tree. I hope this part is completely clear, right? Let's move on with the next step here. Any node that is not restricted as B in any of the M restrictions can be chosen as the root. So this one we know. We have to do that itself, right? Any node that is not restricted as B, that is not restricted as B in any of the M restrictions can be chosen as the root, can be chosen as the root, right? Once a valid root is found, say node center, suppose we can consider this one node center, we have to connect it to all other nodes to build the star shaped tree. We have to connect this one we have to connect it to all other nodes to build a star shaped tree, right? Ensuring center is never any B. We have considered this one, center should never be B, hence restrictions are always satisfied, right here. Hence restrictions are always satisfied. This one we have to keep in mind, right? This point is very important here. Let's come to the example part here. We have 2 4 5 6 are restricted. See here, I have showed already this one somewhere. Yeah, yeah, here 2 4, the center ones, restricted ones 2 4 6 and 5, or 2 4 5 and 6. Here let's consider this one, 2 4 6 and 5, or 2 4 5 and 6 are restricted here, right? So here in this case 2 4 5 and 6 are restricted, so we pick the first unrestricted node, that is 1, that is 1, right? So first always we have picked 1 because we in the middle the node 2 is there, 4 is there, 5 is there, 6 is there. So this becomes restricted. This becomes restricted. This is in between two nodes, A and C, right? So this becomes restricted. This becomes restricted. So the first unrestricted, I mean, the first, yeah, the first unrestricted node that we find here would be 1. The first unrestricted node that we find here is 1. So let's consider this one itself. See here, 1 is the first node that is unrestricted, right? So let me come here in this case. So this would be 1 2 1 3, here 1 4 1 5 1 6 1 7. Why we have considered like this, 1 2 1 3 1 4 1 5 1 6 1 7? Because the maximum number of nodes that we have is 7. From the question itself, in the input they have given 7 and 4 restrictions. We have nothing but here in this case these are the 4 restrictions. M 2 4 5 6, this is nothing but the M restrictions that we have is 2 4 5 6 here. So the first unrestricted node is 1. Along with that we have this one. We will not be considering 1 1 because 1 we are considering from the root. So we'll be going with the next node. This would be 1 2 1 3 1 4 1 5 1 6 and 1 7. 1 1 2 1 3 1 4 1 5 1 6 and 1 7. This is also valid input. This is also valid input for the this one. We have successfully constructed a valid tree with the n minus 1 edges, satisfying all the restrictions, right? So this can also be the this one, what do we call, the output. This can also be the output. They have given different output. They have given different output, and I have mentioned this one clearly several times that the input can have the multiple outputs for this question, right? So the output would be 1 2 1 3 1 4 1 5 1 6 1 7, right? So this is very simple to understand, man. I hope this question is completely clear, right? I hope the approach part is completely clear along with the this one question. So here accordingly with the question, sorry. Now what shall we do? Let's discuss the complexities. As we are completely familiar with the approach, now let's discuss the complexities and then let's write the code. Let's come to the complexities part here. Let's come to the complexities part here. So what would be the time complexity here? The time complexity would be big of n. So why the time complexity would be big of n per test case here? So we will be reading m restrictions. We will be reading m restrictions, we know. We'll be reading m restrictions. In the first example it was 4 restrictions, 2 4 5 6, right? So we will be reading m restrictions plus print. We will also print n minus 1 edges. We have to go with the output, nothing but we have to print the n minus 1 edges. We have to print the n minus 1 edges. So overall time complexity would lead to big O of n per test case. Big O of n per test case here. right? So this is the time complexity. Overall time complexity would be big O of n per test case. So what would be the space complexity here? The space complexity would be big O of n for is restricted center array. So we will be making use of is, so you, this can be any this one, just the array name. So here let's make use of the same name so that we don't get confused while writing the code. So let's make use of the is restricted center array. Is restricted center array, we'll be making use of the is restricted center array. So the overall space complexity will be storing within this array. So overall space complexity would lead to big O of n as well. So the time complexity and the space complexity for the code that we'll be writing in the future would be big O of n, big O of n, right? So this would be the time complexity and the space complexity, right? So just keep this in mind, just keep this in mind, right? So I hope the complexities part is completely clear, along with the what do we call this one approach. Now as we are completely familiar with the approach and complexities, let's start writing the code. Now let's start writing the code. I'll just come to the compiler here. We'll be making use of the fast input and fast output. So let's go, let's import the input output package here. So I'll just go with import java dot input output dot star. So we'll be making use of the utilities as well. So I'll just go with import java dot util dot star. This is fine. So let's go with the class main here. This would be class main. So within this class, let me go with this one, public static void main. So this is fine. So let me delete this one, and also let's make use of the throws input output exception man, or else we'll get the this one error. So I'll just go with here throws input output exception. So this is fine. So within the class, what we'll do first, let's go with the fast input reading, nothing but here in this case buffered uh, reader br equals new buffered reader new, this would be input stream reader of within this one, let me go with system dot in. This is fine. So this is for the buffered reader. Next let's go with the print writer here. So here let me type this one, print writer. This one I'll just go with a pw here, new print writer of this would be system dot out for the output we are considering, right? So this is fine. So next what we'll do, we have to read the number of test cases. To read the number of test cases, I'll be considering the variable t, and we have to read the integers, right? So that is in the form of integers. Input is in the form of integers. So let's do one thing. Let me give here integer dot percent of buffered reader dot read line. We have to read each line, not readable. This is a read line. So this L has to be capital here. So why did, just give me a second. Let me type this one entirely quickly. So yeah, this is fine. So next step is we have to loop through all the test cases. We have to loop through all the test cases, right? So let me write the simple while loop here. We have considered the variable t. So if it is greater than 0, then what we will do, we have to read n nodes and m restrictions. First line itself, in the example one, we have been given 7 nodes and 4 restrictions, right? So we have to read the n nodes and m restrictions. So we can write in this way, string line equals buffered reader dot read line, and we have to split this one. We have space between 7 and 4, right? So we need to split here. So this is fine. This is related to the this one, input output. So also we have to go with the n and m, right? So let me assign n to, so let me copy this one, integer dot percent, right? So this one would be fine, integer dot percent of line of 0. And again, let me copy the same thing here and make the necessary changes for m. So n is nothing but the number of nodes here. M is nothing but the, what do we call, what is m? What is m? One second. N is number of nodes. M is restrictions, right? So percent of this one, line 1. This is fine. So let me let's move on with the next steps here. So we have to track the nodes that are restricted as center. right? Center node itself, we considered that one, center nodes as restricted. So in our case, for the example, when we consider 2, 4, 6 and 5, if you remember, right? So that itself we have to articulate in the form of code, man, simple. So I'll just go with boolean here, boolean. So this one will be is restricted, is restricted center, is restricted center equals new boolean, new boolean of n plus 1, as it is 1 indexed, right? So this is fine. This is fine, we are done with this part. So next, what we have to do, we have to read all the restrictions, means per line we have to read all the restrictions. Line first, in the first line we got 2, in the second line we got this one, 2, 4, 5 and 6, right? 6 and 5. First line 2, second line 4, third line 6, and fourth line 5, right? We have to read all the restrictions. Let's write the for loop. Let's go with the for loop. So we have to read all the restrictions, right? So I'll just go with for int I equals 0, I less than m. Let's increment the I here. So within the for loop, what we will do, let's go with string. uh, let me go with the variable name parts here. We have to read this one, so let me make use of the buffered reader, read line, and again we have, there is a space between every integer, so let's go with the split here, split. So let's leave the space here. This is fine, this is fine. So we are going with the a, b and c. If you remember the question, so we have to go with the integer a, b and c assigned to integers assigned to a, b and c, right? So let's do the same thing here. Let's articulate the same thing, exact same thing that we discussed in the approach. We are articulating in the form of code. So here it would be integer dot percent. This is fine, and this would be parts of 0. This would be parts of 0. So this int b equals, so here that this would be integer dot percent. So here I would have copied the previous line actually. This is fine, parts of 1, right? Same thing, let me do this one for c and make the necessary changes. Let me copy this one, let me paste it over here. Instead of b, let me do it c here. Let me change it to c here. Instead of 1, let me change this one to 2. So this is it. Next, we are successful in reading all the restrictions now. So after doing that, we have to mark the node b as restricted, means it cannot be at the center, it cannot be at the center. So for that, let's make use of the boolean value, and let's set that one to the boolean value true, right? So here let me go with is restricted center of b, the center node, nothing but let's set this one to the value true. Let's set this one to the value true. I hope this part is completely clear, easy to understand, right? So now we are left with finding a node, means we have to find a node that is not restricted to as to act as center. We have to find all those nodes, right? So for first one, first part here, let me assign the center to 1. This acts as counter basically, right? So let's write the simple while loop, because we have to find the node that is not restricted to act as the center. So here in this case, let me write is restricted center of center within the array. So then we have to increment the center, we have to increment the center, right? So this acts as a counter basically in simple terms. So we are done with this part. This part is easy, right? So we were successful in, or we are successful in finding a node that is not restricted to act as center. Now what we are left with basically, we have to construct the star tree. We have to construct the star tree, nothing but we have to connect center with all other nodes. Means 2, 4, 5, 6 we were having, right? We have to connect the centers with all other nodes, 1, 3, then this one we have to connect 2 with all other nodes. We can connect 3 with all other nodes, then not 3 basically, 2, 4, 6 and 5. We have to connect the center with all other nodes. So for that one, let's write the simple for loop here. So this would be for int I equals 1, I less than or equal to n, I plus plus. So this is fine. So within the for loop, let's write the simple if condition. This one will be if I not equal to center, if I not equal to center, then within the if condition, let's go with pw, nothing but the print writer. We have to read every line of the output, we have to display every line of the output. So we'll go with println here. So I have to print, or else it will take system dot out dot something. out.println. So let me print println here. Let me type println. So this is fine. Let me go with center. So not within the strings, man. So let me go with center. Then let's concatenate this one string, this one empty string with the space. Then let's go with the I. This is fine. So we are left with only one part now. So we have to flush the output buffer. Nothing but this is related to input output. We are done with the logical part completely. We were successful in printing the this one as well, the result as well. Now we are left with only one thing. Nothing but we have to flush the output buffer. Nothing but here in this case it is pw dot flush, print output dot flush. This is fine. Yeah, this is it for the code. So this is it for the coding part, right? So I hope this works, right? So before checking with the inputs, let me copy paste the signature starter template. So here let me paste the signature starter template. You can just ignore this one. You just have to just concentrate on the logical part. So let's try out with the different inputs. So here let me copy this one. Let me paste it over here. So let me run this one. So here we are getting 1 2 1 3 1 4 1 5 1 6 1 7. This is for the first input. This is for the first input, this one, this part. So this is for the this input, right? So for this input, 1 2 3 3 4 5 5 6 7 and 6 5 4 with the number of nodes 7 and 4, restrictions is 4. For that output is 1 2 1 3 1 4 1 5 1 6 1 7. This is what we discussed in the approach. For the next input, for the second input, here we have two inputs, they have clearly mentioned, right? For the second input here, 5 3 1 2 3 2 3 4 3 4 5, whatever they have mentioned, for that one we are having 1 2 1 3 1 4 and 1 5 as output. We are having 1 2 1 3 1 4 and 1 5 as output, right? So here this is fine. I hope this part is completely clear, man. I hope this part is completely clear. Now we are getting the correct output. We are getting the correct output for this particular input. So let me copy this one and let me come here. Let me select B here, Omkar and the heavenly tree. So let me paste it over here. So let me hit the submit button. I hope this works for all the test cases. Let's see. So let's wait for some time. This is slow actually. So let's wait for some time. So here you can clearly see this is already showing accepted here. So this part, this is still loading, man. So yeah, here this still stores, shows running here. So we already have, it was already showing accepted in the tool tip, right? Mm, let's wait for some time. Yeah, here now I just had to reload. Now you can clearly see here this got accepted, means whatever the code that we have written works absolutely correct. Whatever the code that we have written works absolutely correct for all the test cases, right? I hope the solution part is completely clear along with the question and the this one, along with the approach and the complexities. For now this is it. Thanks for watching, guys.